Thank you, everybody. I just want to cover a few things today. Basically, I work for Caltrans. I work in the, I'm a senior bridge engineer in the Division of Engineering Services in the Office of Earthquake Engineering and Research. Analysis and research, excuse me. And I just wanted to cover what we do as what we call a PEQIT team. PEQIT team is a post-earthquake investigation team. We're kind of what you would call a forensic analysis kind of team where we go out and we actually look at the damage and then kind of make some assessments. So with that, that's just kind of a short view of what we do, but I'm going to kind of cover this. So in 2022, December 20th, very close to Christmas, we had the Ferndale earthquake with a magnitude of 6.4. You can see here's the epicenter as noted by the red star, and that was about 3 miles off the coast of Ferndale. Let's keep going here. As you can see, it's a little more detailed, but the intersection where the San Andres Fault meets with the Mendocino fracture zone is kind of the area where the epicenter was, and basically some of the most damage. So I'm going to cover two kind of items here. The first item is going to be what we do as a post-earthquake investigation team, and then the second one I'm going to cover on UAS inspections, or what we call drone inspections for some of us. So the first thing is the post-earthquake investigation team. This is the purpose of the investigation earthquake team is we are not first responders. We're basically, we try to get out there as fast as we can because we want to make sure we hit the in situ problems and the damage before construction starts to, rebuild our temporary shore or even remove. We want to get there as fast as we can so that we know what kind of damage we've seen. And then we also get to take a look and kind of with fresh eyes. And so we have to kind of get there fast, but at the same time, we're not first responders. We also, we deploy only after notified by the structures maintenance investigations team that affected areas and that are safe for inspections. That's changed a little bit since we have drones now. We still kind of adhere to this rule, but we also, because we have drones, we can also go in as long as we stay clear and safe of any kind of damaged structures. We can still bring the drones in, deploy the drones, and do our investigations. PEQIT gathers field information about the performance of damaged bridges and highway structures, and then PEQIT evaluates and improves Caltrans' current seismic design code and retrofit procedures. So the PEQIT organization is led by the Office of Earthquake Engineering, which I'm part of, Earthquake Engineering Analysis and Research, and it's in conjunction with Structures Maintenance and Investigations. There are 32 Division of Engineering Service engineers that will support 8 PEQIT teams. So out of those 8 PEQIT teams, there's 6 4-person teams. That's a 24 total, and they're based in Sacramento. There's also 2 4-person teams, total of 8, that are based in Southern California at the Diamond Bar office. The representatives, these engineers represent all offices or subdivisions within Caltrans, which include bridge design, structures and engineering services, and geotechnical services. Also, the material engineering and technical services is available. That is basically the lab, the materials lab, is available for consultation on material-related issues. This is kind of the organization chart. We have our division chief. I'm not going to go through a lot of names because we need to go a little bit on time, but we have our division chief, our subdivision chief, and then our office chief, which is I report to, and then our PEQIT coordinator, who's Bob Tanaka, who's actually in the audience. And then he coordinates with structures maintenance investigation and structures construction. Then there's also stakeholders. These are different committees, the Earthquake Committee, for instance, Seismic Advisory Board, and so on. Those are also stakeholders in our team. Underneath Bob, we have eight teams, basically 1 through 8. Each team will have a team leader. One will at least be a senior bridge engineer. There could be others that are TE civils, which are range A through D. And then we'll usually represent each team with a UAS pilot or a drone pilot. We also have support from the geotechnical staff, METS, the lab, and then structures design technicians are also supporting us. So, what are PEQIT members' duties? Pre-earthquake event, they study the PEQIT process and procedures in the PEQIT manual, as you can see right here, which has been kind of distributed to everybody and created and then distributed. We also attend the annual PEQIT meeting and training. We have a meeting there. And then we participate in PEQIT mobilization drills to keep us kind of clean, kind of frosty on stuff. And then we also assemble and pack field inspection and personnel gear. Then after the earthquake, right after the earthquake, hopefully sooner than later, we go and inspect the bridge and then and highway structures near the earthquake. We write a report on investigation findings, and then we evaluate field findings with Caltrans' current seismic zone code and retrofit procedures. So, what have we learned? What do we gain from PEQIT? Okay, so PEQIT's actually 52 years old. We first were formed at the 1971 San Fernando earthquake, which was a magnitude of 6.6. Some of you may remember that. We learned from that after the investigations and brought our data back that we needed to put cable restrainers for our retrofit program. We also had changed our code for column confinement. So we learned a lot from there. Then in 1989 at the Whittier Narrows, which was a magnitude 5.9, we learned column retrofit program was actually initiated. And then in 1989, the Loma Prieta earthquake, magnitude of 6.9, we improved our connection details. And then in 1994, with Northridge, we had a magnitude of 6.7. The column stiffness balancing within the frame itself, and then with adjacent frames too. The column stiffness balancing was a real big item that we learned from. Then in 2014, we had the South Napa earthquake, which was magnitude 6.0. And then in 2019, we had the Ridge Crest, magnitude 7.1. And then in 2021, we had the Little Antelope Valley, magnitude of 6.0. And then recently, we had the Ferndale earthquake, which was magnitude 6.4 in 2022. Now, the three ones that I'm showing you just above the Ferndale one, they were pretty big, but there was not a lot of damage due to being out in the rural areas. So we didn't see a ton of damage. We did have drones during the Ridgecrest earthquake, but there was just so little damage that we didn't even deploy them. But in the Little Antelope Valley and in the Ferndale, we did deploy our UAS team. So now we want to talk a little bit about the drone inspections and what we do with what their role is with the PEQIT team. Currently, we have 9 Part 107 licensed pilots, 4 from Office of Structures Design, 4 from Office of Earthquake Engineering, and 1 from Structures Construction. 2 are replacing right now, and they're in training. We have 12 drones. All of them are DJI. 9 of them are working drones, and 3 are training drones. Each pilot is assigned 1 drone, and then each working drone camera has at least 1080p capability. You can see here, this is kind of our inventory. We have, for some of you, maybe younger people don't know, but you might recognize some of these. We have 3 DJI Phantom 4s. They're really good they're more stable in the wind. They have a better camera. They have the best camera, actually. And then we have 3 DJI Mavic Pros. They're good working UAS too. They're good overall. They're a little more stable in the wind than the lower ones. And then they have a better camera, and they're also more compact than the Phantoms. And then we have 3 DJI Mavic Mini 2s. They're also good. They're good in tight areas, though. They're not as stable in the wind. but they do have a great camera. They're also 4K, and those are really good drones. Then we have 3 DJI Mavic Minis. They have they're also almost the little brother to the Mini 2, but they don't have quite as good as camera. They have a 1080p on there. Now all of this we have currently, but we are now replacing them all based on legalities through the FAA and also some policies that have changed internally in Caltrans. So we are going to be replacing all of them with what we call the Skydio 2 Plus. They're about the same size as a Mavic. If you guys have seen this, we're going to replace those, and we're going to have a kind of a professional kit, and we'll take those out. Those are a little bit, they're really a good drone, and they're quite capable in tight areas. So now, on December 20, that says 22nd, I'm sorry, that's a typo. December 20th, 2022, unmanned aircraft systems were first deployed at the Ferndale earthquake. Actually, I get this now. It was December 22nd when we were deployed. The earthquake actually happened at December 20th. Magnitude 6.4 in the Ferndale area, and we basically came down to inspecting 3 bridges. That came from some of the data that we would get from CGS, which is California Geological Survey, and we would download that data, and then we'd take a look and see what, we have a program that tells us what are the potential problems that we could be looking for. So we picked 3 bridges for the day. So that day we went down there. The first one we call is Rio Del. It's on the Highway 1 over the Highway 101. It's Painter Street overcrossing, and the next 2 are the Eel River. There's a lot of Eel River bridges up there, so you kind of have to distinguish them in a different way. So we used to call the first Eel River bridge that you see that's with the 101 is the Rio Del. We call it the 16R bridge, just to keep things a little bit more distinguished. And then on the final one is the Fern Bridge, or it's on the Highway 211, and it's also the Eel River, but we call it the Fern Bridge. 3 PEQIT members were chosen. That's me. I was the senior engineer. Daniel is a range D, I think, and then Suresh is also in the mix, and he's actually a trainer. Getting trained, so he's in the training mix. Okay, so during the Ferndale, basically, if you look here, when we went up there at Rio Del, we have painters, and then a little bit higher, we have 16R, and then up to the top where you see the yellow, that's actually the Fern Bridge. Painter Street, there was some damage there. You can see in the acute corner at the abutment, you can see some spalling, and there was some cracking at that shear key. There was some issues there. There was some pre-existing condition to it, so it wasn't all caused by the quake, but there also was some caused by the quake. As you can see, there's some debris at the bottom. That was all caused by the quake. There's also some vertical displacement. This shows about from about 2 to about 5.5. I can see that, yeah, about 5.5. That's not all from this quake. There was pre-existing movement. So basically, talking with the maintenance engineers, we think it's around about 1 inch of displacement. And on the opposite acute corner, you can see there was damage, but you can also see that there was existing damage there that was sort of repaired. So there has been problems there, but not all caused by the quake. And then at Bent 2, we looked at some of the columns, and we took a look and found that it doesn't seem like there's a lot of damage there. Now, so a lot of times our policy is to go out and, inspect and kind of take pictures, be the eyes of somebody that wasn't there. So sometimes we like to take pictures and like to take videography of things that didn't have problems, and that's what we're doing here. We're going to go fly up this Painter Street column Bent 2 just to see if there's anything that we didn't see from below, but we can use the drone to take a look and see what we got. So I'm going to play that for you right now. Now, I was taught, I'm an engineer, I'm not a cameraman, so I was taught, go slow, because if you go fast, you're going to make everybody sick. So I kind of go slow. Maybe too slow, but anyway, we'll take a look. So So I started moving in, started taking a look. There is a little bit of cracking at the top, but very little, and it's very fine cracks. You can see right there, that looks like a crack that could have been caused from construction or something. There's one right there, and you can kind of see this one. This sort of looks like the cold joint there, so I'm not sure that was a crack at all. But basically, an overall view, we saw that there was very little damage. So it's good to document things that weren't damaged as much as it's good to document things that were. And that's our policy. Okay. Let's just keep, I'll go to the next one on this one. Okay, so then we went on to 16R, which is Highway 101 Eel River Bridge. This is kind of a conglomerate bridge. This is kind of a mixture. It's got a truss portion to it, and then it's also got a box girder portion to it. And as you can see, this is the truss portion, and this is the box girder area, single column bents, and basically this is pretty long bridge. Anyway, we were out doing our inspecting, and we had a problem because we couldn't get our data. We had some poor coverage up there because it's pretty rural up there. So we were trying to connect into CGS's website, and we couldn't. So Bob called us. Bob connected with us and said, hey, we just got a call from CGS, and so we went to phones is what I'm trying to tell you. We just got a call from CGS, and they said that you need to go check out Pier 5 because the accelerometer at the top of Pier 5 was showing that we had about an acceleration of about 1.78 G. So we were thinking, okay, we got to go out and check it out. The nice thing was we were real close there. So this is kind of, so what I did is I took the drone, I went to the shore, I flew it out about 100 yards out and about 100 feet high, and took a picture of it, took kind of a view of it. This is kind of an accelerated process of what I showed just for the because of time here, time constraints. Okay, so you can see there's the rocker bearing, then it's on top of a bearing pad, top of a pedestal. There's the accelerometer that read the 1.78 G, but not a lot of damage, not hardly any damage. I kind of wanted to show, okay, so we have these two portions of the bridge that are totally different. We got the truss portion and the box girder portion. So I'm going to see if I want to look on the back column and see if there's any damage from there just because of the differential movement. So I thought, let's just try it. So we went over there and we went in, and this is what we're capturing right now. And we can go in. Again, I go pretty slow. I should have gone a little faster, especially for presentations. But I go in a little slow, and I take my time and go in there and get some good view. Actually, sometimes I even have problems with birds. They don't really like me up there, and they start fighting me, especially if it's a mama bird. I have problems with that, and so I have to kind of weave in and out sometimes. But basically, as you can see, not hardly any damage, so we were good with that one. Now, that doesn't mean that there wasn't damage. There was damage at this earthquake. So there was, and I'll show you some of that, especially on 16R. There's some stuff here. Okay, this will be the north abutment. Basically, there was some movement, definitely some movement up there. You can see, based on this picture, there was a little bit of vertical movement and also longitudinal movement. You can see here that it looks like about 2 inches, and when I talked to the maintenance engineer again, it was not 2 inches of vertical. It was more like about 1 inch. And then you can see down in here, where on the seat abutment, where the soffit and the superstructure sit on the abutment itself. You can see movement due to that white area right there, and this is a close-up of that, and it actually did move about 4 inches longitudinally. Now the final bridge. This is kind of a historical picture of this. This is the Fern Bridge. This is kind of the famous bridge. It had had some damage, not a lot, but some damage. And this was built in 1911, as you can see. This is the approach portion. This has pile extensions, look like they were timber at the time, now they're concrete. Then you have the arch portion. Those arches are actually hollow. So they hollowed them out and then they added actual earth in the hollow portion, and then they would, compact it down to level, and then they would ride their, I guess, horse and buggy back then, but they would ride cars. Later on, they put a bituminous material on top, but it's basically still has the soil portion, the soil inside the arch portion. So this is kind of what it looks like. There's the approaches, slab approaches with pile extensions, and then there's the arch portion. And you can see here, this is some of the damage at the south end of the Fern Bridge. You can see this edge beam saw some compression, so we have some spalling of the concrete, and then we have some buckling of the rebar. And then just above that, we have some railing. That railing is basically old style railing, so it's fixed condition, and they did buckle due to the longitudinal movement of the bridge. And you will be able to see, I'm going to show that a little bit later, just a second, sorry about that. Okay, and then this is the north side, not the south side. This is the north side, and when we got there, like I said, we got there about 36 hours after the quake occurred, and we still were a little we were a little bit late based on seeing any kind of real damage in the portions at the approaches of the north side. They'd already installed some temporary shoring. The contractor was out there hauling these timber piles, timber sections already out there for the temporary shoring. You can also see that there was some spalling on some of the bank caps. There was also some spalling based on these infill walls, lots of stiffness there, and then you can even see there's some existing spall where it was spalling, and then they added concrete. So this is somewhat of an existing condition. This is the south side again, and I'm going to you've seen this before in those pictures. I'm just going to show you what we did with the actual video. And I have a lot of video on this. I would have loved to have shared it with you, but it takes like 2 hours to explain everything, so I don't have the time. So I wish I did and show you some really cool footage of some of this damage here. Again, this was because of the longitudinal movement. There was buckling at the deck level, and so they were repairing that at the time. So they'd already had the contractor out there deployed and is already working on fixing the buckling in the deck at the pavement level. And then this is the other side, and I will turn my drone around and show you a little bit of the damage from the wing wall and the separation of the wing wall from the abutment. The top of the wing wall, the separation was about 1.25 inches, 1.75 inches, somewhere around there, and then at the bottom was about 1/4 inch. And as you can see, there's also damage there. So there was transverse movement a little bit, and there was a lot of longitudinal movement. So I'm going to finish that. Okay, so the conclusions from the December 22nd investigation was that the shorter columns on the approach spans experienced damage at the Fern Bridge, minimal movement and no damage to the rubber isolators at the top of Pier 5 of the Eel River Bridge. The shear keys performed as expected at the Painter Street overcrossing and the Eel Bridge at Rio Dell. The Eel River Bridge at Rio Dell also showed a longitudinal movement about 4 inches. Even though some locations of the bridge saw high accelerations, did not necessarily translate into large displacements or heavy damage, as we saw. The use of UAS drones for bridge inspections has been verified that it's actually faster, cheaper, and safer than the previous traditional methods. So that call from Bob to where I went and flew the drone and took the pictures of that bearing took about 10 minutes. So that's the kind of power you get from inspecting with drones. Thank you.